So before any of the technical material, I want to give you the idea that the whole exam is built on. You don't really need to know any single Claude specific term. But once you understand the idea, the questions start looking very different for you. So here's the situation that you're going to see most often in the exam. Something is going wrong. The model picks up the wrong tool, it skips a step, it invents a value that it didn't have, or it spent some money that it shouldn't have spent. And then you are given four options in general for fixing it. Now, every one of these options is doing one of the three things. Either it's persuading the model, either it's constraining the model, or enforcing something the model can't touch. I'll explain you this by taking a simple example to understand the difference between the three. So, you would need to choose one of these three in most of the circumstances. That's the basic idea for most of the questions. Now let's take an example which you see on your screen, that you have some cars that you want to slow down on the road. So the first option is that you put up a sign of speed limit 30 and you expect the people to slow down. So some of them definitely they would, but some of them won't. So that's the persuading. Now one another option is that you put a speed bump, so some of them would stop, but some of them having good suspensions in the cars wouldn't stop and they would still continue. So that's constrain. You are trying to constrain, but still some people wouldn't stop. Now the final option is that if somehow you enforce the engine itself to have the limit of maximum 30, so you are somehow hard coding it. So that's something I call as enforcement. Now the car cannot exceed, not that because the driver agrees or not, not because it's uncomfortable, just that because the capability is not there. So the driver's intentions have stopped being part of the equation. So these three. I hope the concept is clear. You can keep this in your mind. This concept of the sign, speed bump, engine limiter, hold that picture because everything is hanging around this. So you should have these three in your mind, the three tiers always. Now, well, after this is clear, we are going to move the to compare this in real AI world, how it works. So persuade, you can anything that is made up of words that the model reads to follow. For example, an instruction in the system prompt, a project conventions file, or the Claude MD file that you hear, a description on the tool, and the strongest kind of persuasion, like showing it some examples rather than describing what you want, is beat the descriptions consistently, and that's worth several marks on its own. You should remember it. But every one of these is a sign by the roadside. If you could make an analogy, so it's presentable, readable, but it's ignorable. Now we can move to the constraint to correlate it. So where you change the shape of what's possible to express, instead of asking, for example, for a valid value, you define the set of legal values, so an invalid one gets rejected on the way. Instead of asking for model not to combine two settings that don't go together, you build the thing so that combination cannot be written down. So you split what cannot combine. These are the two pillars that you see on the screen as well. So this will follow to the constraint thing that we discussed now, and the speed bump that we discussed. Now the third one is enforce, where the check lives somewhere the model cannot reach, which means in your own code. So running automatically whether or not the model cooperates. The $500 limit question, for example, if you have a check about limit that you shouldn't exceed and the model agreed to follow it, it's a line in the function that runs before anything happens. So that's the engine limiter. The model's intention stopped being part of the equation. The model has nothing to do. So the correlation, you can see what I just explained. You can also see on the screen. If you want, you can take a screenshot for your notes, and always remember this. So now the rule of choosing, pick the weakest tier that fully solves the problem. Don't reach for the engine limiter always, because a sign would have worked. In those cases you don't need to over engineer, because that will become a wrong answer just as often as under engineering is. Now if a tool is being picked wrongly because the two descriptions overlap, the answer is to fix the descriptions, not to to delete one of the tools, for example. That's like demolishing a house because of a door that is not working. But here's where the marks are certain. Certain words in the question override that entirely. So just remember few words so that you can correlate. So like guaranteed, tamper-proof, cannot be bypassed, must always, every time. When you see those, the examiner is telling you that a sign is not acceptable. So go straight to enforce. Any option made of words or persuasion or constrain is now wrong. So no matter how well written it is, underline that in your notes. It converts a judgment call into a lookup. So keep for the relevant things that you see on the screen. You can take the screenshots whenever you want. So it helps for your notes later on. And then I'll give you an example. A question was asked me how to provide examples to provide a consistency in test naming and structure. And by then, I trained myself to think like an architect. So I reached up the scale and I picked up the persistent conventions file, which came out to be wrong because the answer was examples in the prompt. The two things pinned it there first. The stem said, or the question asked, provide examples. So the question named its own mechanism. If the answer doesn't contain examples, it cannot be the answer, no matter how much better a different approach might be in the real life, or how better AI architect you are. But you have to follow or read the question 1 to 2 times. You have enough time to actually see the stem. Second, the symptom was consistency of the style, and the style is one of the things you genuinely cannot constrain. You can't write a rule that captures like read like our house voice. You can only show it. So when the stem names a mechanism, obey the stem. Your instinct to build the robust thing is a strength on most of the paper, but on these questions it's a liability, and knowing that it's worth more than knowing the material. So you should really follow the stem. You should really see what's there in the question. That's how you can really crack it. One last thing about how this course is put together. So persuade, constrain, enforce is the course version. It's enough to sort most of the options into probably right and probably wrong starting today. But 3 tiers isn't precise enough for the trickier questions because there are several distinct mechanisms inside each one. And the difference between two of them is sometimes the whole question. So here is the plan. Every lesson from here on teaches real mechanisms. And as each one arrives, I'll tell you where it sits. By the end, you will have met all of them. And in the last lesson, or lesson 13, we will assemble the whole thing properly. So you will have the tier from the weakest sentence you can write to the strongest line of the code that you can run. You will be able to build that ladder yourself by then. That's rather the point. No mock test for this lesson. You set test 1 at the end of the introduction. So lesson 2 starts the real material with the biggest domain on the paper. So I hope you like this initial context, and then